Hello, today's video is going to be on transformations, and today we're going to look at translations and reflections, so two different kinds of transformations. The first one, a translation, is simply a slide of an object. And when we slide that object, we can slide it four different ways. We can slide it up or down, or left or right. So we're going to slide it one of those directions. There are three different ways in which we can write translations, three different notations. The first is coordinate notation, then there's transformation notation, and then there's vector notation. Notice that the coordinate notation, all coordinates are at x, y. We can either add an h or we can add a k. The h is going to move, since it's with x, it's going to either move it left or right. Since we see that the k is with the y, the k is going to move it up or down. That h and that k is going to show up in all three different notations. The transformation notation is just the big T for transformation, and we've got it for translation, and we've got the h and we've got the k. The h, again, is going to move it left, right. The k is going to move it up, down. Vector notation, we have these vectors of the h comma the k. So three different ways that we can write that same translation. Our first one, we want to draw the image under the given translation. So first we see that this is going to be coordinate notation. In coordinate notation, which is the one that we use the most often, we see that our beginning point is at xy. So this is the original coordinates of our point. This tells me from my original point, the -1 with the x tells me that I'm going to go left 1. The +4 tells me that I'm going to go up 4. So if I find one of my original points, A, I'm going to go left 1 and up 1, 2, 3, 4. This is the image of A after that translation. So it's no longer going to be A, but it's going to be A prime. That's representing the image of that given point. And I'm going to do that with every single one of my points. So from B, I go left 1, up 1, 2, 3, 4. This is the image of B. From C, left 1, up 1, 2, 3, 4. Connect my points, and now there is my new image under the translation, left 1, up 4. We're going to move every single point in the exact same manner as we did the last one. So describe the translation using all three notations. The first one is the coordinate notation. We are going left 3 and down 5. So coordinate notation, we have to write that original xy. That's telling me that where my original location is. From there, I'm going left 3, so I subtract 3. I'm going down 5, so I do y -5. Transformation notation, we've got a translation. We're going left 3 so that h is a -3. We're going down 5 so the k is a -5. Vector notation, h is a -3 because we're going left. K is -5 since we're going down 5. Our next transformation is going to be a reflection. A reflection is a little bit more complicated than a translation. It requires a little bit more. It is a transformation where every point is mapped onto its image over a line. Transformation where every point is mapped onto its image over a line. And we just referenced this idea of an image in our translation. When I moved A, B, C, this was A prime, B prime, C prime, because those are the image. That's where I ended up after I did my transformation. So for my reflection, I want to reflect our triangle dog over the line x equals 1. So we have to think about that line x equals 1. And this is something that you may need to make a note to yourself about. Any line that is x equals is going to be a vertical line. Anything that's y equals is a horizontal line. So here I have x equals 1. So I'm going to have a vertical line at x equals 1. I'm going to reflect my triangle DOG over that line x equals 1. To do this, all we have to do is count to the line of reflection and then count the same distance on the other side. So if I'm going to reflect triangle DOG from O, I count over 1, 2, 3, 4. Since I'm counting over 4 spots, I've got to count 4 more. 1, 2, 3, 4. That is going to be my image of O reflected on the other side. Remember, reflection is just a fold of a paper. So if I were to fold my paper over this line and I had ink on triangle DOG, this is where my triangle would end up when I folded that paper. G is the same thing, 1, 2, 3, 4. So 1, 2, 3, 4. Here's the image of G over that reflection. For D, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And here we've got our image, our reflected triangle DOG. Remember, we have that D prime, O prime, G prime. It is important that you have that notation. That is what's telling your viewer, whoever's looking at your paper, that that's where it ended up and not where it started. That's the image, not the original. We have another kind of reflection when we reflect over the line y equals x. The one above we reflected over a vertical line. You will do vertical lines and horizontal lines, and for that you count. But this line y equals x, if you remember back to y equals mx plus b, this is your slope and this is your y-intercept. So since I don't have anything added, this tells me that I have a slope of 1 and a y-intercept at 0, 0. So if I'm at 0, 0 right here, I have a slope of 1, I go up 1 over 1, up 1 over 1. What we're going to do is we're going to reflect over this line y equals x. We have a little bit different of a process than if we had our horizontal or our vertical line. It's actually kind of easier. To do this one, all you have to do is switch the x and y coordinates. So when we look at the original here, we have our triangle BAT. The coordinates of B, remember coordinates are always going to be x comma y, so your movement right down. So this is at 6, negative 3. A is at 9, negative 7. And T is at a negative 1, negative 7. So to find our image, where we're going to end up at, we are going to switch those x and y coordinates. So now we've got negative 3, positive 6, negative 7, positive 9, and negative 7, negative 1. So my new point at negative 3, positive 6, that's the image of B, negative 7, negative 9, negative 7, positive 9, that's the image of A, and T is at negative 7, negative 1, that's the image of T. Just like with our reflection of the line above, it is a fold of the paper, but instead of folding our paper along a vertical line or horizontal line, we're folding at a diagonal. And if I were to fold my paper over with ink on this triangle, where would I imagine it to be on the other side? That's all a reflection is mapping an image over a line. And that is it for our two different transformations we did, translations and reflections.